Okay, back to this lecture here. When you look at your tables, and you'll need to be looking at your table B1 in the back of your book on page B10. Okay, the present value of $1. I want to talk about a few things here. I need you to look at the interest percents and the numbers in the table as you go to the right, as interest increases. Remember that interest is the cost of money, basically, right? If money was free, interest rates would be zero. If money is very scarce and scarcity drives the cost up, then 15% would be a very high cost of money. Okay, so I'll take a look at this table here. All right, you should be looking at your B1 in the back of the book. Okay, as interest rates rise, 1 to 2 to 4 to 8, okay, all the way up to 15, these numbers clearly are getting smaller as you go to the right. Let's look at n equals 5. Okay, if I wanted to wait 1 year to get a payment, whatever it was, $1,000, $10,000, doesn't matter. If I were to wait 1 year at 1%, I'd still be getting, I'd only be discounting about 5%. I'd get 95% of that money, okay, right up front. All right, at 15% though, take a look at that. If interest rates are 15%, think about it. If I could have the money now, I could go invest it and make 15% interest. That's awesome. Okay, over the course of 5 years, that 15% compounds. 4 of the 5 years there, it's going to compound. All right, and so what this number here means, this 0.497, this means it's very, very punitive. It's a huge discount, about half the total dollar amount. In other words, if you were going to pay me $1,000 a year from now, I would take $497 right now because I could go and invest it at 15% and it would catch up to the $1,000. So what this means is the discount is much more steep because the cost of money is so high. When rates are high, it's much, much more punitive for me to wait to get my money. Okay, so as interest rates increase, you got to understand the factors in your table drop dramatically. Okay, because I don't want to wait when the interest rate is high. I still don't want to wait when it's low, but it's much less of a big deal. Okay, think about it. At 0% interest, if money was free, what's the present value of a future payment? Well, $1,000. There's no interest to be made. Okay, so these numbers might differ for different periods, but if there was a 0% column right here, they don't even have one because it would all read 1.0 right down the line. Okay, so there's some details about how these trends work. Hopefully that makes sense to you. All right, here we're going to talk about annuities now. Different than present value of a one-time payment, sometimes called a balloon payment or a lump sum payment. I've been talking about $1,000 a year from now. What if you got $1,000 or if you got $10,000 every year for a long period of time? Okay, you would call that an annuity or an annuity. It's a series of equal payments at specified equal intervals. A couple stipulations. It's got to be equal dollar amount each period. It's got to have interest periods of equal length. These will usually be a year, but sometimes they'll be quarters. Sometimes they'll be a 6-month period, biannually. Sometimes it'll be monthly. Okay, but for the most part, we're going to use a year. And you got to have the same interest rate for all periods. Okay, so you must understand, for it to be an annuity, all 3 of these conditions must be met. Annuities are very valuable because here's a typical business example. If you're trying to buy a franchise and the people selling it to you said, don't worry, business is going to net 10 grand a month for at least 5 years, you've got to find the present value of this cash flow stream at 8%. Here's what you would do. You set up a cash flow timeline. Remember that time starts at 0, so you just make a point in time, year 0. A year from now, I'm going to get 120K. 2 years from now, I get another 120K, and so on and so forth all the way through year 5. Well, you can't just add all these up because of the concept you're just learning here. Time value of money. Okay, 5 times 120 is not the same as what you're really going to experience. Okay, so what I'd like to do is I'd like to discount this 120K in year 5. I'm going to have to bring it back 1, 2, 3, 4, 5 years to get it back to today, because today is when I make the decision. This 120K in year 4, I'll bring it back 1, 2, 3, 4 years. This one, year 3, obviously I'll bring it back 1, 2, 3, and so on and so forth. The first 120K I would get, I'd bring it back here. And this model is not even perfect because actually you'd be getting 10 grand a month, and I've just simplified them and treated it like 120K at the end of each year. Okay, so for simplicity's sake, let's move forward. For an annuity, I want you to take a look at your tables here And on the other page of your book, you'll notice that tables B3 and B4 both deal with the present value of an annuity. Actually, B4 is a future value of an annuity. We'll come back to that. But in table B3, you'll notice a couple differences. This is for multiple payments. Therefore, every line except the first row, every row is greater than 1.0. Look at the previous table, B1 on the other page. Every value was less than 1. In B3, every value is more than 1, except for that top row, because that's just like a single payment. So what you do with an annuity is you're going to get these 5 payments. So you've got to say n equals 5. In other words, I go right down the left-hand column and I go periods equals 5. And at 8%, I skip over and I should see the number, I believe 3.1, I got the wrong number there, 3.9927. Let me go to my table here. Appendix table, this is present value of annuity, present value tables. I don't have the right table up here. So I'm going to go back to my PowerPoint. You'll have to look at the back of your book and trust that 3.9927 is the number you get from I equals 8 and n equals 5. Okay, so when you just multiply that 3.9927 times the principal, which is 120 grand a year you're going to get, it's this times this, it's going to be 479,124. Okay, notice the same setup. Present value equals a principal times a factor. You just went to a different table. This table is calculated for getting all these payments annually. Okay, like that. Not a one-time payment 5 years out. You must understand that. Okay. So hopefully that example is clear to you. All right.